So you've got these incredibly powerful AI models today, right? But they all share this one huge fundamental problem. They're brilliant, but they're trapped. The real challenge for anyone building with AI right now is how do you get these digital brains to actually do something useful in the real world?
This analogy is just perfect. It nails the issue completely. A powerful foundation model is brilliant, yeah, but it's stuck. It's totally isolated from anything happening right now, locked inside its training data. It's memorized the whole library, but it has no hands to turn a page and no eyes to see what's going on today. It can write amazing things, but it can't actually act on the world. So, what's the fix? How do we connect that incredible mind to the real world so it can actually see things and do things? Well, the solution is actually pretty straightforward, and it all boils down to one powerful idea: tools. All right, let's really unpack this core problem. A lot of people in the AI space call it the brain in a jar, and for good reason.
And here's the crazy part, the real paradox. A model can spit out the perfect Python code to check the weather, but it can't actually run that code. It can think, but it can't do. And bridging that gap from thinking to doing, that's the entire goal of agentic AI.
So how do we get it out of the jar? Well, we've got to give the AI senses and actuators. Its eyes and its hands. And in the world of AI, we just call these tools. So what is a tool, really? Simply put, it's just a program that an AI can use to do something it can't do on its own. It's the bridge that lets the AI reach outside of its own digital mind and actually touch the world. And these tools really only do two main things. The first is to let the model know something new, like fetching a real-time stock price or reading the latest news headlines. And the second is to let the model do something real, like sending an email or booking a meeting on your calendar. Know or do. It's pretty much that simple. Now, the community kind of breaks these down into three main flavors. First up, you've got your function tools. These are the ones developers write themselves with really clear instructions. Then you have built-in tools, like the Google search function inside of Gemini, that just kind of work automatically behind the scenes. And third, and this is a really cool idea, you have agent tools, where one agent can delegate a task to another, more specialized agent. Think of it like a manager handing off a really tough technical problem to their expert engineer. Okay, so we have tools. Problem solved, right? Well, not exactly. Connecting all these tools created a brand new headache, a massive, chaotic scaling problem. This was the integration nightmare. People called it the N by M problem. Just imagine, for every N models and M tools, you had to write N times M custom, hand-coded connectors. It was a total mess, completely impossible to maintain and scale up. The solution that the industry is starting to rally around is something called the Model Context Protocol, or MCP for short. It's an open standard designed to be like a universal adapter, a single plug-and-play way to connect any tool to any agent. It finally separates the thinker from the doer. MCP works with this really clean three-part setup. First, you've got the host. That's the main app running the show. Next is the client, which handles all the communication. And finally, you have the server, which is the program that actually provides the tools and executes the commands. The separation is what makes it so modular and scalable. Now, a standard like MCP is a huge leap forward, for sure. But, building this stuff in the real world, well, that brings a whole new set of challenges to the table. So let's go over 5 essential rules for designing great tools. 1. Documentation is everything. It is literally the model's only instruction manual. 2. Publish high-level tasks, not complicated low-level APIs. 3. Keep the tool's output short and sweet to avoid overwhelming the model. 4. Describe the action you want, not how to do it. Let the AI figure out the implementation. And 5. Provide error messages that actually help the agent learn and fix its mistakes. Let's double-click on that third rule about concise output. This is a huge deal. If your tool spits back a giant spreadsheet, you get what's called context window bloat. It eats up your tokens, it makes everything slow, and it can actually confuse the AI. The fix is dead simple. Don't send all the raw data. Send a short summary, or even better, just a link to where the full data is stored. Okay, but what if you have thousands of tools? You can't just stuff all of their instruction manuals into the AI's brain at once. The clever solution here is called tool retrieval. You basically use a fast search to find just the top few most relevant tools for whatever task is at hand, and you load only those into the context. It's smart and it's super efficient.
All right, now for the big, scary topic, security. Probably the single biggest worry when you put agents out into the wild is a classic vulnerability called the confused deputy problem. It's where a clever user can trick a trusted AI into doing something they themselves are not allowed to do. Here's how it plays out. A user who doesn't have many permissions crafts a really sneaky prompt. The AI, which is a trusted part of the system, takes the prompt and makes a request to a powerful tool server, say one that can access sensitive data. Now, the server sees the request coming from the trusted AI, not the sketchy user, and it just does it. Boom! The user has just laundered their malicious request through the AI to get access they should never have had. So how on earth do you stop this? Crucially, the solution isn't built into the MCP protocol itself. It's built around it. For any serious real-world deployment, you have to wrap the entire system in existing, battle-tested security like enterprise API gateways that handle authentication and authorization before a request ever even gets to the tool. So if there's one thing to take away from all of this, it's this. Foundation models are the powerful brains, absolutely. But they're useless without the ability to act. They need well-designed tools connected by a standard protocol to be their hands and eyes in the digital world. And remember, applying these principles, good tool design, layered security, is going to make any agent you build more effective and more reliable. This stuff is universal, whether you end up using MCP or not. This leaves us with a final and really critical question. As these autonomous agents become more and more woven into all of our systems, how do we design them to act on a user's authorized intent and not just blindly follow their literal and maybe even malicious command? That is the real challenge.